welcome back to part 2 of this crash course on concentration. Keep in mind this is predominantly meant for secondary 4 students, but if we remember back in part 1, we talked about concentration, which was the ratio between the amount of solute and solution. We visited this formula, concentration is equal to mass divided by volume. We also talked about concentration in parts per million. We talked about it in aqueous solutions as well as in other solutions. But today in part 2, we're going to be talking about concentration conversions, mass volume, mass, and volume for volume percentages in concentration. So let's dive in. So the first formula we're going to visit is the mass volume percentage. And so this formula resembles a lot like our original concentration formula, except that we're multiplying by 100 because we're dealing with percentage. So we need to remember in these conversions that the units of measurement are so important. So we always need to write down what we know with the unit of measurement. And so concentration is calculated in percent mass volume. Our solute is in grams, and the solution, the total volume, is in milliliters. So we're dealing with grams and milliliters in this formula. The second formula is the mass by mass percentage for concentration. And so the formula looks like this. We take our concentration, which is a percentage in mass, and we take the mass of the solute divided by the mass of the solution, again, times 100, because we want a percentage. So keeping in mind mass in grams for the solute and the solution in this formula. So make sure we always look at those units of measurement. And the final formula that we're going to talk about is the volume by volume formula, which looks like this. So again, we're calculating concentration, but this time, instead of mass, we're talking about volume. So it's the volume of the solute divided by the volume of the solution times 100. So again, our concentration is percent volume, but then we also have our solute that's in milliliters and our solution that's also in milliliters. Times it by 100, we get a percentage as an answer. So let's hop into a first example practicing some of these formulas. In order to prepare a 0.250 kilogram sample of bronze, 30 grams of tin is combined with copper. What is the percent concentration of tin in this bronze sample? So right away, we know we're dealing in percent concentration. So I have 3 formulas to pick from, and I want a mass formula because I need to write down what I know first, right? So I'm dealing with concentration. I don't know if I know it's going to be in a percentage, but I also have my mass of my solute and the mass of the solution. The mass of the solute being 30 grams and the mass of the solution being 0.250 kilograms. Now remember, we want grams. So we're going to convert those kilograms. We're going to times by 1,000, divide by 1 kilogram, and we get 250 grams. So this is a mass concentration problem. So we're going to use that formula. Concentration is equal to mass of the solute divided by mass of the solution times 100. So we're going to put in our values, 30 grams divided by 250 grams, and multiply that by 100, and we get 12% mass per mass. So the concentration, the mass per mass percent concentration of tin in bronze is 12%. Let's do a second example. A veterinary technician needs to prepare a 0.9% mass per volume saline solution, NaCl, so salt. She needs 6 liters of the solution. How much sodium chloride should she use? So we know our concentration. It's given to us in percentage. Remember, units of measurement tell us what we need. So concentration is 0.9% mass volume because we're dealing with liters and we're dealing with grams. So we don't know our mass. That's what the question's asking us. So we need to find our mass, but we're given our volume in liters. But remember, we need that to be converted into milliliters. So we're going to times that by 1,000 milliliters, divide by 1 liter, and we get 6,000 milliliters. So we're going to use concentration is equal to mass divided by volume times 100. If we look at what's given to us, that's going to tell us what formula we need to use. So we're going to use this guy. We're going to plug in our values. So 0.9% mass volume is equal to mass divided by 6,000 milliliters times 100. We're going to cross multiply. So we're going to do 0.0090 grams per milliliter times 6,000 divided by 1. And that's going to give us an answer of 54 grams. So the veterinary technician needs 54 grams of NaCl to prepare the saline solution. Let's do one more percentage concentration example. A gaseous solution of nitrous oxide in oxygen can be used in dentistry sedation to help patients manage pain and anxiety. If 6.3 liters of nitrous oxide is used to prepare this solution, what volume of oxygen gas is required for the concentration to be 42% volume per volume. So right away, volume per volume, that's our formula. So our concentration is 42% volume per volume. We're dealing with the volume of the solute, which is 6.3 liters, and the volume of the solution, but we're trying to look for the volume of the solvent. Let's ask ourselves a question. Which formula correctly determines the volume of solvent in a gaseous solution? Is it A, the volume of the solvent equals the volume of the solution plus the volume of the solvent? B, the volume of the solvent equals the volume of the solution minus the volume of the solute? Volume of the solvent is equal to the volume of the solution for C, or is it D, the volume of the solvent is equal to the volume of the solute plus the volume of the solution? The answer is B. So we have our two formulas down here. We're going to take our concentration, which is the volume of the solute divided by the volume of the solution times 100. And we're going to take that solvent and we're going to equal it to the solution minus the solute. That's how we're going to find it. So we're going to take our 42% volume per volume, and we're going to take our 6.3 liters and divide it by the total volume of the solution times 100. Now remember, we're going to cross multiply, so 6.3 liters times 1 divided by 0.42 to find that total volume of our solution. So we get an answer that is 15 liters. Now that's the volume of the total solution. We want the volume of the solvent. So we're going to take our 15 liters and we're going to subtract the 6.3 liters of the solute so that we get 8.7 liters. So the approximate value is 8.7 liters of oxygen should be used. So another aspect of concentration is when we do conversions and where we want things to all be kind of on the same playing field with the same units of measurement. And so let's do an example. A pistachio spread is a type of nut butter made with pistachios and several other ingredients. The concentration of pistachios in a high quality spread is at least 45.5% mass per volume. Based on the information provided in the table, determine which of the following samples meet the high quality standard. So we're looking at 45.5% mass volume. We have two samples here. We have the 260 grams of pistachios in 0.6 liters of spread, and we have 121 grams of pistachios in 220 milliliters of spread. So we're going to have a look at our solutions for this. So first thing we need to do though is we need to take that percentage and turn it into a decimal so that we can better solve for it. So we're going to use that grams per milliliter. So we're going to take our 45.5% mass volume, we're going to divide it by 100 so we turn it into a decimal and no longer a percentage. That's our first step. Now we're going to hop over and we're going to compare the two together to see which one is the better quality. So if we look at our first sample, we don't know its concentration grams per milliliter, but we do know that that sample has 260 grams of mass per 0.6 liters. Now remember, grams per milliliter, so we have to turn that liter into milliliters. So we're going to times it by 1,000 milliliters and divide by 1 liter, so we get 600 milliliters. So we take our solution, we take our formula. We don't need the percentage, we're just calculating concentration. So concentration is equal to mass divided by volume. So we take 260 grams, divide by 600 milliliters, and we get 0.433 grams per milliliter. Now, if we remember back in the question, we know that 0.433 grams per milliliter is less than the spread criteria, which is 0.455 grams per milliliter. So probably not the best option. So we'll try sample number 2. So in sample number 2 from the table, we know that the mass is 121 grams and the volume is 220 milliliters. We already have it in grams per milliliter, so there's no conversions needed. We just need to put it right into our solution. Concentration is equal to mass divided by volume, so 121 grams divided by 220 milliliters, and we get a 0.550 grams per milliliter. And 0.550 grams per milliliter is greater than the criteria, which is 0.455 grams per milliliter. So we are going to be choosing sample number 2. So let's do one final example of conversions. List the following concentrations of aqueous solutions in ascending order, so from smallest to biggest. So we have a 19% mass volume, we have 212 grams per liter, and we have 134,000 ppm. So we have all of these different units. We take a deep breath and we are going to tackle this. We're going to put them all in the same playing field with the same units of measurement so we can compare them the same way. So if we look at our first concentration, it's at 19% mass per volume. And so that one we don't really need to do anything with. Let's just keep it as mass per volume. But if we take our second one, we can we can convert the 212 grams per liter into a mass volume percentage. So we're going to take what we know. We have our 212 grams per liter. We're going to times that by 1 liter because we want those in milliliters. So we're going to times it by 1,000 milliliters. So we get a concentration of 0.212 grams per milliliter. So now we're dealing with, again, grams per milliliter. We're going to times that by 100 because we want that percentage mass volume. So we get 21.2% mass volume. So again, concentration number 1 is 19%. Concentration number 2 is 21.2%. So we're going to do the same thing with our 134,000 ppm. We're going to take that concentration, we're going to use mass divided by volume, and we're going to times it by a million. That's because we're in ppm. So we're going to take that 134,000 ppm and divide by 1 million to get our grams per milliliter, which is 0.134 grams per milliliter. But remember, we want a percentage. So we're going to take that grams per milliliter and times by 100. So we get 13.4% mass volume. So if we are going in ascending order, we have 134,000 ppm, then we have our 19% mass volume, and then we have our 212 grams per liter. And that's it. We've learned about our 3 formulas dealing with concentration, and we've talked about the useful conversions that will help us. So don't forget, units of measurement and concentration are so important. And don't forget to check back in part 1 if you need a little bit of review on parts per million.